This is Math Expressions Unit 7, Lesson 5. And let's go ahead and, of course, write our name up here, our number, and then over here the date that you're working on this page. We'll do that with every page. This is a fairly long lesson. It's 6 pages long. Some of them will go by pretty quickly, but I think you're probably going to break this up into a day or two, or different sittings, not just in one big sitting, but maybe. We'll see how it goes. In this lesson, we're going to be talking about angles and triangles and other kind of shape things. So first off, we're going to start off with types of angles. And over here in our little vocabulary box, we have these words ray, angle, and right angle. So we're going to talk about those right now. So let's first thing, let's talk about a ray. So a ray is a part of a line that has one end point. That's that little dot, right? Like right here, like right there. That's the little dot. That's the end point. And then it continues on forever. So that's what this arrow means. It just goes on and on forever. I think of this as like, have you ever seen those laser pointers or something like that, and the light shoots out. So this is called a ray, right? So it has an endpoint, one endpoint, and then continues on forever in one direction, not changing direction at all, right? So to draw a ray, make an arrow to show that it goes on forever. That's what that arrow is. So you can see all of these have a starting point or an end point, right? I think of them as a starting point, and then they go on from there forever. That's what that arrow means. Just like a laser light will go on and on forever. If you shot it up into space, it would go on until forever. It would never stop. All right, so that's what a ray is. Now we're going to talk about angles. So two line segments, or two rays, right? Because we talked about a ray as a line segment. Two line segments or two rays that meet at an endpoint form an angle. So this is a little confusing. So here's the starting point, here's the starting point, and they meet there in the middle. They cross each other there. And instead of going on forever, they just stop. So if it's not a straight line, and if it has a turn like those do, that turn is called an angle. And an angle that forms a square corner, that's what this little thing right here, that square in the corner, we call that a right angle. It's like taking a right turn. You're going along and you turn, and it's a right turn. So if you could put a square, if you could fit a perfect square in the corner, we call that a right angle. That's over here too. Okay, so some angles, right? So we can either have a perfect right angle, straight up and down, straight across, or those angles could be smaller than a right angle, like this one right here, right? It's more closed. I think of those as closed. Or some angles could be larger. They could be more, I think of this as more open than a right angle. So we have ray, right, which is just a line segment. We have an angle, and then we know what right angles are, right? So let's come down to this one down here. These angles are named with a letter in the corner, which is often what happens, right? So like this one, this angle is called V. W, X, Y, and Z, right? So each of those have a name. So let's look at number 1. Which of these angles up here, V, W, X, Y, or Z, are right angles? Which of those are right angles? Well, hopefully you chose W, because that's the only one that has that square, that box in the corner. And in these lessons, they will always show us with that box if the angle is a right angle. So let's go ahead and look at number 2. Which of those angles are smaller or more closed than a right angle? Go ahead and see what you think. Yeah, I think X and Y are smaller or more closed than a right angle. And so number 3 over here says, which of the angles are larger or more open than the right angle? Go ahead. What do you see? Yep, I see V and Z. All right, so when you're ready to go, we'll go on to the next page. All right, so if you're ready, let's go on to the next page. And even though there's not a line for it, let's go ahead and just be in the habit of putting our name and number and the date up there at the top. All right, so in the page before, on the lesson before, we learned about what array is. It's a kind of a line that has a starting point and then it goes on forever. We learned about what angles are, right? And then we learned what a right angle is. We learned that angles can be more closed or smaller than a right angle, or they could be more open or larger than a right angle. So in this lesson, we're going to be learning about triangles. We're going to be telling about or describing triangles by the types of angles that are inside of them. And it says right here that triangles can be described by the types of angles they have. And you see this word triangles is highlighted. That's our vocabulary word here. Triangles, you guys know that tri means three, right? And then angle just means angle, right? So tri is Latin or Greek for three, and then we have angles. So inside a triangle, we have three angles. And in these triangles, we can see that one angle is a right angle because they give us that square in the corner where that angle is. So those are right angle triangles. In the next one, in these triangles, three angles are smaller than the right angle. So all of the angles inside of those are smaller or more closed than the right angle. So these are smaller than a right angle. So we're kind of comparing them to a right angle, right? And then in the orange ones down here, these triangles, one of the angles is larger because you can only have one inside a triangle. You can only have one angle that is larger than a right angle. So again, we're kind of comparing it to a triangle with a right angle. So you can see like this one here in this corner, that is more open. It is larger. Here's another one right there. You can see those angles are more open, right, than the right angle. All right, so let's use what we just learned. Use these triangles K, L, and M to answer some questions here. So let's look at number 4. Which of those triangles has one right angle? Go ahead. Yep, right there. There's that angle. So it is M. There's that square in the corner that tells us it's a right angle. All right, let's look at number 5. Which of these triangles has three angles that are smaller than the right angle? Go ahead. Yep, K. You guys got it. And then that means which triangle has one angle that's larger? Yep, the only one that's left, L. Good job. All right, so before we go on, in this lesson, we learned that we can describe or tell about triangles by the types of angles that they have inside them. On the next page, let's go ahead and go on to the next page. This time, well, let's go ahead, and start off with our name, number, and the date that we're working on this page. And then when you're ready, let's go on. All right, so on this page, we're going to tell about triangles again, but this time not by the type of angles that are inside of them, but by the number of sides of equal length. So the number of sides of equal length. So right here it says you can also describe triangles by the number of sides that are of equal length. So equal, that means the same, right? So in these triangles, all three sides are of equal length. It's kind of one of those, I think, of a perfect kind of triangle, right? All the three sides are of perfect length. But in these blue ones down here, there's two sides that are of equal length, right? So like this side and this side, this one and this one, right? Those are of equal length, right? But in this and these kind of light yellow ones, none of the sides, no sides are of equal length. And then, so let's go ahead and come down here. And it says use these triangles, B, C, and D. Let's use these to answer some of these questions down here. So let's go to number 7. Which triangle has three sides of equal length? Go ahead. Yep, C. Good job. Number 8. Which triangle has two sides of equal length? Yep, D, you got it right here. So this side and this side are of equal length. And then, of course, so which triangle has 0 sides? And, of course, that is B, the only one that's left. All right. All right, so just a quick review. In the previous lesson, we learned to describe or tell about triangles by the types of angles that are inside them. On this page that we just finished, we learned to describe triangles by the sides, the number of sides that they have that are of equal length. And so we're going to go ahead and go on, and we're going to put those two together. So here we go. Let's go ahead and put our name and our number and the date up there that you're working on this page. And then when you're ready, let's go on. It says to describe triangles by types of angles and the number of sides of equal length. So we're going to put those two together that we just did. So we're going to use these triangles, M, N, and O, to answer questions 10, 11, and 12. And we're going to complete the sentences. We're going to fill in the blanks on these. So let's look at number 10. Triangle blank. So which triangle has one angle larger than a right angle and has blank sides of equal length? So which of these triangles has one angle larger than a right angle? Let's answer that first. Which triangle has one angle larger than a right angle? And there's only one. And yep, so hopefully you chose O right here. This angle is larger than a right angle, right? It's more open. And how many sides of equal length do you see there? Do you see any sides? So this is funny. We're going to put, this is the letter O up here, but this is the number 0 right there. They look like the same, right? Kind of confusing. All right, so let's look at number 11 then. Which triangle blank, has one right angle and how many sides of equal length? Go ahead and answer that, and I'll show you what I do. All right, so hopefully you saw that this one right here, there's our cue that tells us that's a right angle. So this is M, right? And now, how many sides of equal length? You kind of have to turn your head, but I believe that those two sides are of equal length. So it has two sides of equal length. And then number 12 says, triangle blank has three angles that are smaller than a right angle, and how many sides of equal length? So go ahead and answer that one, and then I'll show you what I came up with. All right, so angle N, because that's the last one, right? And how many sides of equal length do you see? Well, I see this one and this one over here, those sides. So I see two sides of equal length on there. So let's continue down here. Use these triangles, P, Q, and R, to answer questions 13 through 15. And again, we're going to put the P, Q, and R and complete those sentences. So kind of continuing on. So let's look at number 13 first off. Triangle blank has three angles smaller than a right angle and has how many sides of equal length? Go ahead and answer that. So we're smaller than a right angle and of equal length. Okay, so this one is kind of a little bit confusing. So has three angles smaller than a right angle. And that could be Q and it could be R, right? So this could have two different answers. So I'm going to go ahead and let's just say Q. So let's say that Q is the one we're choosing because this does not, this corner looks potentially like it might be a right angle, but remember they'll show us with a square in that corner if it was. So that's not a right angle on that one. So all of these are smaller. All of these angles are smaller than a right angle. They are not squares in the corners. Okay, so I would say Q, and it has 0 sides of equal length. None of those are the same length, right? Okay, let's go on to number 14. Triangle blank has three angles that are smaller than a right angle, and it has how many sides of equal length? So go ahead and answer that. Pause the video and answer that, and then I'll show you what I'm going to do. All right, so the only one we could choose is R, because you can see that P here has this angle is greater than or more open. It's larger or more open than a right angle. So the only one that works is R. And it looks like they are all like 3 sides of equal length. And so number 15, we're going to guess that that is angle P here. Let me erase that so I can see a little clearer. It has one angle that is larger. So yep, that's P. How many sides of equal length do you see there? Yeah, again, I don't see any sides of equal length on that one either. All right, so hopefully you're ready to move on. And we are going to leave triangles, but we're going to take what we learned from triangles and add them to other kinds of shapes. So let's go ahead and look at the next page. And of course, let's start off by putting our name and number and the date that you're working on this page on the top. And then when you're ready to go on, let's go on. All right, so we're going to go from triangles to polygons. And over here in our vocabulary box, we see 3 words, polygons. Now, poly means many. Poly equals many. Gon is another word for angle. So many angles. Right? And then we have 2 other words. We have this word concave and convex. So I like to really focus on the cave and the vex to help me remember what these 2 words mean. And we'll see what those are as we go through this lesson, okay? So the first one is a polygon. So let's look over here. So a polygon, it is a flat, closed figure made up of line segments that do not cross each other. So there are several things in there. It's flat, so it's not 3-dimensional or anything like that, right? It is closed figure, which means it doesn't have any openings. It's like if you were stuck inside there, you couldn't get out. There was no doorway out or window out. And it's made up of line segments. So a line is something that doesn't bend, right? A line is a straight, and then those lines do not cross each other. So we have, what is that? 1, 2, 3, 4. We have 4 descriptors of a polygon. A flat, closed figure made up of line segments, and those segments don't cross each other. Okay? So right here, let's see if we can apply that. So it says to circle the figures that are polygons. So let's look at number 16. Is it flat? Yes. Is it closed? Is there any openings? Nope. Is it made up of straight lines? Yes. And do any of the lines cross each other? No. So that one, yep, that is a polygon. Okay, so let's continue. And actually, if you want, you could pause the video and go on and answer these and then start it back up and see what I do, or else you can just continue with me. Okay, so number 17. Is it flat? Yes. Is it closed? Well, yeah, kind of. Is it made up of lines? Yep. Do they cross each other? Yes, they do. So not a polygon, right? Number 18. Let's look at that one. Is it a flat? Yes. Made up? Is it closed? Yes. Is it made up of line segments? Yes. None of them cross each other? Yes. That's a polygon. So we can just kind of go on. 19. Yep. That's a polygon. 20. No, because these are not straight lines, right? I see a straight line here and a straight line here, but not this one. This one's all curvy, so that's not a polygon. Number 21, yep, number 21 is a polygon. Number 22, nope, because that's an opening, right? You could pour out stuff. And number 23, definitely not. They're not even connected. They just kind of look like railroad tracks. So not that one and not that one. All right, so we've learned what a polygon is, right? So now let's talk about 2 different kinds of polygons. A figure or a polygon can be concave or convex. So in concave polygons, there exists a line segment with endpoints inside the polygon. So let's look over here. And so you can see that this figure comes down in, right? Comes down inside. Whereas this one, they stick out. And so think of a cave. A cave goes in, right? You go into the mountain or into, right? So think of that. That helps me to remember that which is which. Concave means it goes inside. And then a convex is kind of like the on a house, the roof on a house. So that's how I remember, right? So I'm going to come back over here again. In a concave polygon, there exists a line segment with endpoints inside the polygon and a point on the line segment that is outside the polygon. So that's what these are, I guess. But a convex figure has no such line segment. So it's just the steeple of the on a roof, right? But this one goes in. It goes in. So concave is like a cave. It goes in. Convex, it's just like the on your house. So let's go ahead and look down here. Which of these figures are convex and which are concave? So go ahead and we're going to have to write. There's not a quick way to write those words, so we're just going to write convex and concave underneath each of those. You can pause the video, go ahead and answer those, and then check yourself, or you can just go along with me. So I'm looking at number 24 here. I don't see any that go in, so this is convex, right? And I can just go ahead and write con on all of these. Con. Okay, on number 25 kind of looks like a whale, but you can see this one does go in, crashes in, so that is concave. That's a bad E. This one, number 26 right here, this also goes in, right? So that's also a concave. And number 27, none of them go in, so it is convex. All right. So let's, you can get ready for the next page. All right. So we've learned about, in this lesson, in this page, we've learned about polygons, two different kinds, concave polygons and convex polygons. So on the next page, the last page of lesson 5 here, let's go ahead and go on to that. And again, before we start, let's go ahead and just use this space up at the top, name a number, and the date that you're working on this page. So we're going to look at different polygons and how they're named. We're going to name polygons. And polygons, right here, polygons are named according to how many sides they have. So we can talk about a polygon, any polygon, by not necessarily its shape, but how many sides it has. So I'm looking down here at 3 sides. We know that 3 means triangle. We've talked about quadrilaterals, right? 4 means quad. 4, like a 4-wheeler is a quad, right? You're used to that. A 5-sided figure is called a pentagon. There's a famous building in Washington, D.C. Called the Pentagon. The home plate on a baseball diamond is in the shape of a pentagon. 6-sided are called hexa. 8-sided are called octagon, like an octopus has 8 arms. And then 10-sided are called deca. Deca, 10. These are all Greek words that come from us from thousands of years ago, a couple thousand years ago, when the Greeks were developing math, and that's where these words quad, penta, hexa, octa, and deca all come from. So I'll show you how we're going to count each side, and then we're going to name them, okay? So to keep from double counting a side, I'm going to recommend that we just start by crossing a line. So as we count, we cross a line. So 1, 2, 3, 4, 5, 6. So I can see that I've counted because I crossed them out, I can see that I've counted all the sides and I came up with 6. So this is a hexagon. We call that a 6-sided figure, a hexagon, right? So that's going to be your job, is to just go through and count the sides and then name them. And again, it doesn't matter necessarily the shape, it's the number of sides. All right? And that's it. Pretty quick. We're done. When you finish this, we are done with lesson 5.